All right, so for example 7, it says find an inverse of f of x equals x squared, and graph both functions on the same scale. I think I already did it in previous videos, but that's fine. Okay, so we have y equals x squared, and now switching the places and solving for y. So in order to unsquare y, we need to take a square root, right? But we already so we already talked about the shape of this function. So let's graph 4, 2, 3, 4. Okay, so my x squared function is goes through 1, 1, and 2, 4. Same on the other side, but the other side I'm actually gonna make it, I'm not gonna make it solid because we already said that we're gonna restrict the domain in order for it to be 1 to 1. So this branch here exists, but I'm not gonna focus on it. I'm gonna have the inverse function, which is symmetrical about the diagonal line, right? The diagonal line is right there. I don't know if you can see it, but I don't want my graph to be too busy. So 2, 4. So I'm taking these points, the main points for the graphing parabola, and inverting them. So this one is 1, 1. So inverted is going to be 1, 1. And this point is 2, 4. So inverted is going to be 4, 2. So it's to help me graph this function. So this is a right branch of y equals x squared, and this is y equals square root of x. All right, so that's how I will graph both the function and its inverse. Okay, so here's another one. It says find the inverse of a function using reflection about the identity line. Okay, so I don't have the formula for the function, right? So I have to use the graph only. Okay, so let's put the line to help me. I could also look at the points. Like for example, here I have a point 2, 1. So I'm gonna graph 1, 2. That's a reflection on the other side. And then what else? So this point 4 and 2 becomes 2 and 4, like this. And now, yeah, and this tail is gonna go there, the tail of the function. And okay, so also the intercept 1, 0, 0, 1. Okay, now I think I'm ready to graph it. So it's gonna go something like this. Okay, so a reflection about the diagonal line or the identity function, y equals x. Try it graph f and its inverse from example 8 on the same scale. Actually, I think that one is a little complicated, so I'm actually gonna do it with you. Actually, I want you to pause here and try to do it yourself first, and then we can compare the results, okay? So go ahead and pause here. And here's our example 8. So this was our inverse function, and this was our original function. So if we go through the transformation, this is the transformation of 1 over x. It's 1 over x function, but it's stretched by a factor of 2. Also, it's moved over 3 units to the right and also 4 units up. All right, so I'm gonna graph this function and the inverse. Let's see how the inverse is gonna look like. This is what I got for my f of x, 2 divided by x minus 3 plus 4. So I have asymptote at x equals 3 and also y equals 4. And I also stretched it by a factor of 2. So now I'm gonna graph the inverse. Again, I'm pausing here. So again, the inverse is also a transformation of 1 over x, but it is moved 4 to the right and 3 up. And yeah, stretch by 2. So here's my final sketch of these functions. And so the inverse function, the asymptotes are in green, so it goes through 4 on x and through 3 on the y, and it's in purple. The graph is in purple versus black for the original function. And I hope that you can see how they are symmetric about this this diagonal line. So here's the line. That's a diagonal line. And do you see how these graphs are mirror images of each other, like across that line? And I also use Desmos for you to graph those lines, and this is what they look like. Some more accurate drawing than mine, chicken scratch. Okay, so hopefully you can see it a little bit better. And here's the line. Here's the identity line. All right. So this concludes this section.